Introduction. An electronic circuit is composed of various components which are known as electronic components. Electronic components usually have two or more leads which can be fitted into the PCB to form a working electronic circuit. Classification of electronic components. Electronic components can be broadly classified into two types. Passive components. Passive components are the ones which do not require external energy to operate. They depend on the power provided from the AC circuit. Also, they cannot generate energy of their own. Active components. An active component is a device that has an analog electronic filter with the ability to amplify a signal or produce a power gain. Types of passive components. Some of the passive components are resistors, capacitors, inductors, sensors, transducers. Introduction of resistor. Resistors are the basic component in an electronic circuit which is used to generate voltage and current in the circuit. International standards like IEC, International Electrical Commission, and ANSI, American National Standards Institute. These standards are useful in having common resistor sizes, markings, values, and measurement methods. The standard resistor values are 10 ohms, 12 ohms, 15 ohms, 18 ohms, 22 ohms, 27 ohms, 33 ohms, 47 ohms, 82 ohms. Color bands on the resistors are used to represent the resistance values on each of the resistor. There are 4-band, 5-band, and 6-band resistors. From the figure we can see that the first and the second band represent the numerical value of the resistor, the third band is a multiplier to the power of 10, and the fourth band is a tolerance level. Resistance calculation using color codes. First band, second band into third band. Hence the value of that resistor is red 2, violet 7, so 27. Brown 10, so 27 into 10 equals 270 ohms. Gold 5% tolerance. Resistance 270 ohms, 5% tolerance. According to Ohm's law, power is calculated as a product of voltage and resistance. Type of resistor. There are two types of resistor. They are fixed resistor, variable resistor. Fixed resistor. The resistors made up of ceramic body and are cylindrical in shape with definite resistance values are fixed resistors. The resistive element could be either carbon film, thick film, or a wound wire element. The properties of fixed resistors depend upon the type of fixed resistor used. A carbon film resistor has 5% tolerance, power rating of 0.125 watt to 2 watts, temperature coefficient of 250 to 450 ppm per K. A metal film resistor has 1% tolerance, power rating of 0.1 to 5 watts, and temperature coefficient of 10 to 250 ppm per K. A wire wound resistor has 1% tolerance, power rating of 1 to 200 watts, and temperature coefficient of 20 to 400 ppm per K. Types of fixed resistor. Based on the type of material used in constructing a resistor, it is classified into carbon composition, carbon pile, carbon film, and metal oxide film. Carbon composition is made up of carbon clay composition with plastic coating around it. Carbon pile is made up of a stack of carbon discs compressed between two metal contact plates. Carbon film is deposited on an insulating substrate and cut into a thin resistive path. Metal film is cylindrically shaped and coated with nickel chromium. Metal oxide film is made up of tin oxide. Application of fixed resistors. The application of the fixed resistors are protecting other components from damage due to excess current, dividing voltage to different parts of the circuit, timing applications where a fixed resistor is used along with a capacitor to control time delay. Variable resistor. Variable resistors are the resistors in which the resistance can be continually altered and is not definite. A variable resistor has 3 terminals, out of which 2 are connected to the ends of a track and a third terminal is connected to the wiper. The motion of the wiper allows in increasing and decreasing resistance. There are 3 main types of variable resistors: potentiometer, rheostat, and trim pot. A potentiometer is used to divide the voltage. It consists of resistive element. Two terminals are connected to electric contacts at the ends and a wiper is in between. The wiper slides on the resistive element, making electric contact. Rheostat is the most common way of varying resistance. A semicircular insulator is wound by a resistance wire, and the wiper slides from one turn of the wire to the next. Trimming potentiometers, also known as trim pots, are similar to potentiometers, but instead of having a knob for adjusting voltage, they are mounted with a screw. They are turned with a screwdriver and used for few adjustments. Applications of variable resistors. Rheostat is used in power control devices like light bulb. Potentiometer is used in audio volume in AV circuits, measurement of angles, and tuning of circuits. Trim pot is used in calibrating instruments, AV circuits. Comparison between fixed and variable resistors. Fixed resistors are resistors with a definite resistance value, whereas variable resistors vary in resistance either manually or automatically. Fixed resistors are either made up of carbon film, metal foil or wound wire, whereas variable resistors are made up of carbon composition, cermet, ceramic and metal, conductive plastic, wire wound. Fixed resistors are used to prevent excessive current in the circuit, whereas variable resistors are used to adjust volume and gain controls in the circuit. Introduction to capacitors. A capacitor is a passive electronic component used to store electric charge. The unit for measuring capacitance is farads. The standard capacitor values are 1, 10, 100, 510, 910 picofarads. Capacitors are also marked with color bands to denote value. The first two bands are the first and second digit, whereas the third band denotes the multiplier. Symbol for capacitor is as shown. Capacitor tolerance is the value which determines the extent to which capacitance can vary from actual capacitance. It ranges from -20% to +80%. Temperature coefficient. The temperature coefficient is a maximum change in a capacitance with change in temperature. It is measured in ppm per degree C, parts per million, by degrees Celsius. The factors affecting capacitor behavior are as follows: breakdown voltage, equivalent circuit, Q factor, ripple current, instability, dielectric absorption, leakage current, and voltage reversal. Breakdown voltage. The voltage at which dielectric capacitor becomes conductive is called breakdown voltage. Equivalent circuit. All capacitors also have some resistance called equivalent series resistance, which adds up to the impedance. Q factor. It is used to measure efficiency and is a ratio of its reactance to its resistance. Ripple current. Ripple current is a component of AC which generates heat in the capacitor. Instability. As the capacitors begin to age, capacitance of certain capacitors decreases. Dielectric absorption. Capacitors containing dielectric material show dielectric absorption, which generates voltage. Leakage. Constant exposure to heat causes leakage in dielectric. Current and voltage reversal. Current reversal occurs when current changes direction, and voltage reversal occurs when there is change in polarity, and these reversals cause excessive heating in capacitor. Types of capacitors. Based on the types of materials used in the capacitor plates, the following types are the most common types of capacitors: ceramic capacitors, film power capacitors, supercapacitors, and variable capacitors. Ceramic capacitors. Ceramic capacitors are made up of ceramic and metal, where metal acts as the electrode and ceramic as the dielectric. This type of capacitor is used in applications of high frequency and high current pulse loads. Film power capacitors. In film power capacitors, the dielectric films are drawn to a thin layer surrounded by metallic electrodes on a cylindrical wiring. Polypropylene is used as the dielectric. Supercapacitors. Supercapacitors are electrochemical capacitors with no specific dielectric in it. The storage of charge is obtained by either separation of charge or redox reactions. Variable capacitors. All the above-mentioned capacitors are fixed capacitors which cannot vary their capacitance. A variable capacitor can vary its capacitance by mechanical motion. The two methods used to vary capacitance are tuning and trimming. Applications of capacitor. Capacitors are used in designing filters. They are used to reduce the impact of electric noise in digital circuits, also to separate the AC components of a signal from DC components. Large capacitors are used to store energy. Safety with capacitors. Capacitors retain charge for a long time even after the power is removed. So before touching the circuit, ensure that the capacitor is fully discharged. Introduction to magnetic materials. All materials have inherent magnetic characters formed due to the movement of electrons. Transition metals, lanthanides and their compounds are used as magnetic materials. The properties of magnetic materials are paramagnetism, ferromagnetism, antiferromagnetism, ferrimagnetism. Introduction to inductor. An inductor is a two-terminal electric component which resists changes in electric current. It is a conductor wire wound into coil. Construction of inductor. Inductors are made up of insulating wire like copper wire wound on a plastic or ferromagnetic material. The inductor symbol is shown in the diagram. Working. When current flows through the coil, a magnetic field is set. This field restricts the flow of current. Once a field is created, then current is passed normally through it, thus resisting any change in the flow of current. Characteristics. The resistance of the wire used in winding the coil is assumed negligible. The amount of induced voltage in a coil is directly proportional to the rate of change of magnetic field of coil. The induced voltage of the coil is proportional to the number of turns. Types of inductor. The following are the types of inductors: air core inductor, ferromagnetic core inductor, variable inductor. Air core inductor. It is an inductor which has its coil wound on non-magnetic material like plastic or ceramic, and there is only air present in between the windings. Ferromagnetic inductor. It is an inductor which has its coil wound on a magnetic core made up of ferromagnetic or ferromagnetic material. Laminated core. It is a type of ferromagnetic inductor whose core is made up of thin steel sheets or laminations. Ferrite core. It is a type of ferromagnetic inductor whose core is made up of ferrite. Toroidal core. It is a type of ferromagnetic inductor where the coil is wound on a straight rod-shaped core. Choke. It consists of coil of insulating material wound on magnetic material. Variable inductor. It is made up of ferrite magnetic core which can be slid or screwed to change inductance. Features of inductor. All inductors are magnetic materials. They have a path of ferromagnetic material. The path is closed so that the magnetic field lies in the ferromagnetic material. Specifications. The value of inductance is measured in Henry. Inductive tolerance is usually in the range of -5% to +20%. Maximum current rating, which specifies the maximum current that can pass through the coil. Applications. Inductors are used in signal processing, filtering out some frequencies, removing hums from DC output. Applications. Inductors are used in signal processing, filtering out some frequencies, removing hums from DC output. Introduction to transformers. It is an electric device that transfers energy between two circuits using electromagnetic induction. Operation of transformer. The operation of a transformer can be explained with the help of these two laws. Electric current produces magnetic field across the conductor, and a change in magnetic field induces voltage at the ends of the conductor. Features of a transformer. There is no copper loss in the windings. There is no inductive loss. Flux is present only within the magnetic core. Construction of transformer. Based on the application, a transformer consists of a core made up of ferromagnetic or ceramic material and a coil made up of some insulating magnetic material or copper wires. Transformer oil is used for cooling transformer. Losses in a transformer. These are the losses in a transformer: winding loss, hysteresis loss, eddy current loss, hum, stray loss. Winding losses. Current flowing through windings causes heating and losses due to heating. Hysteresis losses. Each time the magnetic field is reversed, some energy is lost. It is hysteresis loss. Eddy current losses. Eddy currents are present in the ferromagnetic core and cause resistive heating in the core. Hum. Magnetic flux causes the core to physically expand slightly and it results in a humming noise. Stray losses, inductive leakage and radiation losses are all stray losses in an inductor. Types of transformers. Based on the purpose of transformers, they are classified into power transformers, instrument transformers, RF transformers, audio transformers. Power transformer, used for high voltage transmission purposes. Instrument transformer, they are used to operate instruments at high voltage, high current circuits and safely isolate the control circuit. RF transformer, transformers used in radio frequency applications. Audio transformer, they block radio frequency signals, split and combine audio signals. Introduction to diodes. A diode is an electrical device which allows current to flow easily in the circuit. The most common form of diode is a semiconductor diode. Symbol of a diode. Introduction to semiconductor diodes. Diodes made up of one or more atomic element are called semiconductor diodes. Usually, they are made up of silicon, gallium, aluminum, or arsenic. Doping in diodes. This process of injecting impurities is called doping. It creates two layers, p-type and n-type. In p-type, positive electrons are created and in n-type, negative electrons are created. Functioning of semiconductor devices. The semiconductor material in this diode is the one that provides the physical properties of the diode. Materials earlier mentioned like silicon, gallium, etc. are injected in the diode with impurities. Types of semiconductor diodes. These are the following types of diodes: avalanche diode, crystal diode, light-emitting diode LED, photodiode, varactor diode, Zener diode. Avalanche diode. When the reverse voltage is higher than the breakdown voltage, it conducts in the reverse direction. Crystal diode. It consists of a thin sharpened metal wire pressed against a semiconducting material. LED. Light-emitting diodes are made up of direct band gap semiconductor, which produces wavelength from UV to IR. Photodiode. They are very sensitive to light and are used in solar cells. Varactor diode. These are used as voltage-controlled capacitors. Zener diode. Characteristics. From the graph shown, it is observed that no current flows when the diode is forward biased. The forward characteristic is non-linear. A very small leakage current flows in the negative side. P-N junction diode. When the P-type and N-type materials are placed near each other, a junction is formed which allows current to pass through one direction and blocks the other direction. This type is our basic P-N junction diode. Schottky diode. The Schottky diode is a diode with low forward voltage drop and fast switching action. Reverse recovery effect. When moving from the conducting to the blocking state, the internal storage charge in the diode has to be discharged. This results in reverse flow of the current. It is called reverse recovery effect. Applications. Diodes are used in constructing logic gates, converting AC to DC, measuring temperature, and waveform clipper. Introduction to Zener diode. A Zener diode is like any semiconductor diode which allows current to flow in the forward direction, but also in the reverse direction during a certain voltage called breakdown voltage. Symbol of Zener diode. Operation of Zener diode. A normal semiconductor diode usually is damaged due to overheating when reverse voltage is applied for long duration. But in a Zener diode, a large amount of current can be passed through it and only a small change would be observed in the voltage level. It is usually used in reverse bias condition. Types of Zener diodes. Based on the breakdown voltage, Zener diodes can be classified into two types: surface Zener and subsurface Zener. Surface Zeners. Breakdown voltage 6.8 to 10 volts. NPN transistor, where collector and emitter are at cathode and base at anode. Charges accumulated in the diode cause Zener walkout. Subsurface Zeners. This diode is similar to surface Zener, the only difference being that the avalanche is deeper inside the structure. Thus, there is no Zener walkout and the Zener voltage is maintained. Introduction to bipolar transistor. A bipolar transistor is an active semiconductor device formed by two p-n junctions which amplify electric current. Structure of bipolar transistor. A bipolar transistor consists of three differently doped regions called the emitter, the base, and the collector. NPN. It consists of p-doped semiconductors between two n layers. PNP. It consists of n-doped semiconductor between two layers of p-doped material. Heterojunction transistor. This type is similar to bipolar transistor and can handle very high frequencies. Regions of operation. Bipolar transistors have 5 distinct regions of operation. They are forward active, reverse active, saturation, cutoff, avalanche breakdown. Forward active. The base emitter junction is forward biased and the base collector junction is reverse biased. Reverse active. The base emitter junction is reverse biased and the base collector junction is forward biased. Saturation. When both junctions are forward biased, it is in saturation. Cutoff. When both junctions are reverse biased, it is in cutoff. Avalanche breakdown region. Due to the electric field created, there is current flowing through good insulators. It is avalanche breakdown. Functions of bipolar transistor. The functions of a bipolar transistor are to amplify current and to regulate current. Specifications. Voltage between collector emitter, voltage between collector base should be above 12 volts and voltage between emitter base should be between 5 to 6 volts. Applications of bipolar transistors. BPT is used in an amplifier to amplify input waves in a microphone. It is also used as a switch. It also is a part of integrated circuit, IC. Testing of diodes. Diodes can be tested using multimeter. Set the multimeter to diode function. Anode to positive, cathode to negative. Note down the voltage drop. Transistors can be tested using multimeter. Black probe, base, red probe, emitter, collector. Red probe, base, black probe, emitter, collector. If the readings don't change with the change of probe at base, then the transistor is bad. Introduction to op-amps. Op-amp is a high-gain voltage amplifier with differential input and single-ended output. Working of op-amps. Op-amp amplifies the difference between the inverting and non-inverting input. It works in the open-loop mode and closed-loop mode. Characteristics of op-amp. An ideal op-amp has the following characteristics: infinite open-loop gain, infinite input impedance, zero output impedance, infinite bandwidth. Op-amp made of transistors. The diagram shows discrete op-amp made of transistors with a gain of 100. This is not widely used. IC741. IC741 is the most common type of op-amp. It consists of differential amplifier, voltage amplifier, and output amplifier. IC741 features. IC741 has the following features: zero common mode gain. The offset null pins are used to place external resistors. Hybrid. A hybrid op-amp consists of 3 triodes and coupling capacitor at the input. Applications. It is used as low-pass or high-pass filter. It is also used in electrocardiogram amplification. Resistor versus inductor. Resistor is used to reduce the magnitude of the voltage, whereas inductors are used to shift the AC voltage phase. Resistor versus capacitor. A capacitor stores charge, whereas resistor uses potential energy to generate power. Capacitor versus inductor. Both capacitor and inductor store energy, but capacitor stores it in an electric field, whereas inductor stores it in a magnetic field. Transistor versus diode. A diode consists of 2 layers, whereas transistor consists of 3 layers. A transistor works like diodes placed back to back. Diode versus Zener Diode. Diodes can work in both forward and reverse bias, but Zener diodes are meant to work only in the reverse bias mode. Transformer versus transistor. A transistor contributes to power gain by taking power from external power supply, whereas a transformer is used for impedance matching. Transistor versus op-amp. A transistor needs biasing to turn it on, and an op-amp, although made up of transistors, does not need biasing and can amplify the difference. Simple circuit. A car reverse horn. It starts blowing as soon as the car is in the reverse gear. The circuit of reverse horn consists of resistors, capacitors, transistors, and diodes. Battery of 12 volts is supplied to provide power to the circuit. The power supply passes through the transistor, which acts as a switch and provides power to a Zener Diode. It regulates the current and passes it to the transistors, which generate sound waves, which are again amplified by another transistor.